Buenos dias, señor y señoritas. And that's the end of my Spanish. We're going to switch to English for the rest of this. That's as good. Even though you're our closest, well, not you, but Spanish speakers are our closest border. Can I tell a joke? You want a joke? Okay. So the joke's in English, so you have to answer in English too. What do you call somebody who speaks 3 languages? Trilingual. Good. So he gets a bonus. You guys are all got to speak faster. Don't make the organizer win. What do you call somebody who speaks 2 languages? Bilingual. What do you call somebody who speaks 1 language? American. Close. English don't even speak American. They don't count. Okay, so that's the end of my... Thank you. I have tons of really, as my kids can attest, I have tons of terrible bad jokes. And if you're not nice to me, I'll start telling them. So today I'm going to talk about converging big data and application infrastructure. That's my name. I work at Red Hat on OpenShift. And there's all the coordinates where you can find me. That's a 0, the Steve 0. Any Ingress players in the audience? Any Pokemon Go players in the audience? Actually, so on a quick aside, because we have plenty of time, because the other sessions haven't even gotten out. As big data people, you should think about playing Ingress. Do you people know what Ingress is? How many people, raise your hand. This is not hard. You don't have to speak. You can just raise your hand. I know a lot of Spaniards are shy about trying out their English, so just raise your hand instead. How many of you know what Ingress is? Okay, so Ingress is, for most people don't, Ingress is pre-Pokemon Go. I'm assuming everyone here knows what Pokemon Go is. Is that a good assumption? Yeah, okay. So Ingress, the company that made Ingress is Niantic, and they're the company that made Pokemon Go, and it's a big Google project, and what it is you walk around with your phone on a team, and it's this massively multiplayer augmented reality game. And the reason why I think you should play it is you should think about the possibilities of that game and look at the organization and all the teams and efforts that go in and think about that from a big data perspective. That's actually why I started playing, especially the geo part. Okay, all done with the aside. Let's go on to the talk. So the goals for today's talk are pretty simple. It's a brief introduction to how things have evolved. I've actually been doing big data for quite some time, back before it was called big data. Talk about what we have now. Demo of this in practice. So I'll probably do about a 15-minute demo, 20-minute demo. That's what I'd like to spend most of my time on. I hope you enjoy watching things happen rather than just me talking the whole time. And then have fun. So as you can tell, I'm a very informal speaker. I was warned by the organizers that it was unlikely that you guys would ask questions in the middle of my talk, although I would like that. I like questions as we go along. I'm fine with waiting for them for the end. So the assumptions about you have written a web app at some point in your life, even if that's just like an HTML page. Is that a good assumption? Yes? Sí? Uno? Okay, sí. And you know some basics of Spark, or you've played with big data. This is not going to be, so for those of you who came to see a lot of Spark, you're going to be sorely disappointed. This is the part where when you get on the plane and the pilot comes on and says, if you are headed to London, this is the proper plane. If London is not one of your destinations, now is the time to get up and go on a different plane. So this is not going to be a very heavy Spark talk, okay? Because the point of my talk is to show how we can now actually integrate web applications and big data applications into the same platform at the same time. So where are we coming from? So I just want to set some context on this because I think some people, although a lot of people in the audience look to be around my age group, some people don't appreciate how good we have it now. So I'm going to set the context back from when I started or even before I started. So before, when you used to do big data, you used to go to a room like this. Usually the rooms I used to go to didn't have any windows. They were usually in the basement of some university building, and you had a VAX, some sort of VAX terminal, VT3200 terminal, and it was black and green, right? And you would sit there, and it would smell terrible because everybody had been living there for days, doing their master's or their PhD work, right? And you would all be sitting there, and you would log into something like that. Does that look familiar to anybody? Does anybody recognize that? You can call out. I'll give you a bonus for it. Who said it? It says up on there what it is. It's SAS. How many of you have used SAS? Oh, really? Nobody's used SAS here? The software package? I feel very old now. That's not nice. Some people raise their hand at least, so I don't have to feel so bad. So SAS was like the gold. Are you all like R users or Python users where you write all your own statistics there? Is that more of what everybody's doing? Yes? See? So since you answered for the whole group, and everybody's doing that now. This is old school statistics. This is how you used to do statistics, right? And it was the gold standard. R was a dream in somebody else's. I don't even think it was a dream yet. I'll get to when R finally comes in. But this is what you do. You sat down at a terminal and you worked with this, and there was a wall of manuals, probably half the size of the screen, that were all the SAS manuals, right? And that's how you did big data analysis. And this is what it looked like when you put it in. And the reason why I put this slide in here is for one very simple part. It's this yellow block in the middle. That yellow block was how you entered your data. Unless you had a tape somewhere that you could load, right? But you had to actually type in all your data in the same place where you did your applications. So obviously big data was not something you did because you just wouldn't want to sit there and do more than when you had a big data set was like I had 400 observations. That's a big data set. I can say a lot, right? And then you would do these proc prints and stuff, and then what would come out of this process is this. And does everybody recognize that printer? That's like one of those big printers where you would go up to the window and knock on the window and say, hey, can I have my printout? This wasn't even from your own machine, right? And so and then you would go through each page and looking for the right page, and you'd be like, ooh, look, my coefficient is this or something like that. And this is what I did when I did my first training models, right? And when I was learning statistics. And what did apps look like at this time? And we're done. Right? There was no apps at that time. I mean, it was a desktop app or it was something, but there was Windows. I don't even think Windows was out when this stuff started, right? And then so when we get to this, I'm going to leap a little bit forward, and we get to something which is I kind of consider the next era, and maybe it's corresponding to when I was learning statistics, when I was doing my PhD, and what's happening now. So when I was doing my PhD, this becomes more popular, right? There's actually a desktop app. I can load data by putting in a floppy drive. I can load data maybe by downloading some stuff off the internet at this point. How many of you recognize S Plus or know what S Plus is? Who knows what S Plus is? Really? People. Okay. S Plus, do you think it's related to R? Think of the name. R, S, right? So S was a language that came out of AT&T Bell Labs, which tons of stuff came out of. But AT&T Bell Labs derived S by a couple people, and then there was a company formed around it called S+, and they wrote the statistical language. And then open source starts to take off, and that's what gets you to R. Because S+ you had to pay for, and a whole bunch of people, especially in the statistics community and the data analysis community, were like, I don't want to pay for all this expensive software, and I want some way that I can share my algorithms and we can all look at them to make sure they're correct, right? Because like with SAS or S+, you could never see the source code. So you actually had to trust that whoever had implemented the algorithm had done it in a correct way. And so R was the movement that came out of that, which we have all now benefited from. All right? And so this is what you would use this, like desktop GUI to do your stats. I specifically say you cannot use Excel for stats. There was I know people right now don't do Excel stats anymore, but during this time period, there were tons of people using Excel for stats. And it always used to frustrate me. And this is what web pages look like. Right? This is a place that I used to work at back in about 2000, 2001. And that's the state of the art for web pages. So there wasn't really much going on. Does that jive with everybody's feeling about what's going on? Did you learn a lot of stuff already that you weren't expecting to learn? That's all bonus content for you. Now you can go to cocktail parties and say, oh, did you know where R came from? Why, it started as S and S+, but then it went open source. And very popular at parties. People love talking about that. So I consider now the time of actually paradise. And I don't know how many people actually appreciate it, right? So we've had some great developments in computers which have entered us into this age. People have figured out how to make commodity hardware do great things. So at that time when you were running like S+ on your desktop, you were paying $4,000 to Dell to get the high-end machine. right? Or if you needed a server, you were paying $10,000 for just a RAID array. And you were paying $20,000, and you wanted to put as much CPU and RAM into this machine that came just from Dell. And it was specifically from Dell or HP or somebody. But Google and others have taught that you can do a lot of stuff with commodity hardware. You don't need the big servers and the big iron as much anymore. Specifically like, what am I thinking of? The VAX machines, mainframes. Distributed software has gotten better. So back when I was writing web apps and doing statistical analysis, it was one machine. Like when you wanted a database, you wanted a new machine. And that was going to be your database machine. And then you were going to have an app machine, and that's where your web server was going to run. But there was no sense that this was going to be distributed over multiple machines. And we've gotten really good over time now to building distributed software, which is combined with the vanilla hardware that we can use, we can do a lot more for a lot less in terms of money. Programming languages have actually gotten easier. How many of you started learning program before the internet? Right. So you two, you three. Now, since you were volunteered to raise your hand, you're now on the spot to answer my next question. Get ready, it's a hard one. When you started programming, what was one of the ways you picked your language besides it being taught in your class? Sorry? Libraries, that's a good one. And related, so libraries, what you had is stuff to add to it that actually shipped with the product because it was hard to download stuff. But related to the word libraries or biblioteca, what was the other thing you always looked for? For me, it was always books. Like who had the most number of books in their programming language in case I got stuck? But now programming languages have gotten easier, and we have the internet, and we can all copy and paste off of Stack Overflow to do anything we need to do, right? So programming has become much easier thanks to Stack Overflow. And CS has put a lot of effort now into statistical libraries, right? Statistical libraries used to be part of statistical packages. So it was in SAS, it was in S+, it was in R if you needed to do statistics. Otherwise, you were writing a lot of boilerplate code. Not boilerplate. I should say you were writing a lot of hard custom code yourself to do statistics in a generic language. And what's happened over time is a lot of different programmers have built a lot of different statistical libraries so that they are now just available as libraries in many different languages. And the browser has grown up during this time period. Most people now target the browser when they're building applications, and it can do a lot of really interesting things. So the example framework I'm going to show today, so we're almost at the demo time. Are there any questions about anything I said? No? Okay. So the example framework, I'm going to be using Docker containers. Does everybody know what containers are? Right? They're lighter than a VM. They slice up the operating system. They give you a bit of the kernel. So they make things really quick to start and are not very resource intensive. I'm going to be using Kubernetes via OpenShift. OpenShift is Red Hat's distribution of Kubernetes. And Kubernetes is a way to take your Docker containers and spread them out over a cluster of machines and orchestrate them and schedule them and be able to scale things up and down and have IP addresses and routing and all the stuff you want to run a platform on with containers. I'm going to show a Node.js and Python application. And I'm going to show Spark. And I'm going to show Spark via Oshinko. Does anybody know what Oshinko means in Japanese? Any Japanese foodies here? Does anyone know what daikon is? No, a daikon is a radish in Japanese. You know daikon radishes with your sushi? Okay. Oshinko is pickled daikon. It has nothing to do with the project at all. It's just these people like the names. But so Oshinko is a way to bring Spark into OpenShift and Kubernetes. So I'm going to show all that together. So that's the stack I'm going to show today. And the only thing I want to show I want you to memorize this entire picture. There'll be a quiz at the end of the talk about how each piece fits together and what color it is. No, I'm not doing that at all. I actually want you to ignore most of what you see. What I want to point out about this is a Kubernetes or OpenShift cluster. There's the master, and there's all the nodes running. And what we get with this architecture is not only can we run web servers, right, but we can also run database servers on the same architecture. And now with that same architecture, we can also run big data processing libraries like Spark, like Hadoop drivers. You wouldn't put Hadoop directly into here, at least not yet, but you can run the stuff that runs on top of Hadoop that does all the analysis. Right, so I'm going to show Spark running alongside, do we have Mongo in here? No, I'm going to show Spark running alongside Mongo, alongside Python, alongside Node, all in the same architecture. So this isn't that you have one private, and so this is the benefit here again. And I don't think I emphasize this enough, which is it used to be that you would do all of your analysis on your desktop, and then you would take that analysis and move it to a web server and show it on a web server. Or you would have a cluster of analysis machines, and you would do some ETL out of the database on a regular basis, and you'd have the data scientists, or what they were called back then were statisticians, right, would go in and do all their work, or their business analysts would do all their work. They would make a PDF report, and then they would put it up on the web server. Or they might have a few interactive graphs. But these were two very separate worlds. And there was like a high priesthood in each of those worlds. They were the data scientists, and all they worked in was their data science clusters and their data science world. And then there was the web developers and app developers, and they lived in their very different world. And with the convergence and the way the hardware has evolved, we can actually now run these in the same world, and you can share between those two groups much easier. It doesn't mean that suddenly web developers are big data scientists or big data developers, but what it means is those two groups can actually work much closer together. Or the web developer can actually start playing with big data, or the big data person can start doing some web stuff, right, and prototype much easier than they could before. And so that's what I'm going to be showing some of today. So I consider this winning. I should have picked something with football, but cricket was the only one that was Creative Commons licensed. Okay, so we're going to see it in action. And so now we're done with slides for a while. So what I'm going to show you first, this is the OpenShift console. Right? And OpenShift has projects. And I've already spun up the entire project in case the network fails me. So I have the project running, but I'm going to build the entire project from scratch right here. And so what we're going to do is we're going to make a driver that will give us the ability to make a Spark cluster on the fly. And then we're going to put an app inside of it. And then that app will actually train against a data set. And then we'll actually be able to play with the results using a web server. Okay, and I'm going to try to attempt, if the network gods are with us, I'm going to attempt to do that all in real time. All right, so I'm going to make a new project. And a project is a namespace for all the pieces I want to put together, kind of like an application. So the first command, oh, it's probably going to tell me I'm not logged in. Oh, I forgot the dash. Yeah. So I'm going to log into my cluster. And I've made my new project. So now if I go back to my web interface, there's my new project, except I spelled it wrong. Great. Let's make a new one. Okay. So now I'm going to go inside that project, and there's nothing inside of it yet. So the first thing I'm going to start doing is putting in the framework that will actually be able to spin up Spark clusters on the fly. How many of you have actually spun up a Spark cluster before, or installed and gotten a Spark cluster running? Anybody here? One person? Two people? How long did it take you to do? This is not a test to see if you're some superhuman. I'm just trying to get an idea. The first time you tried it, how long did it take? Days? Okay. See, brave person. I owe you a drink later. Come outside, I'll give you a glass of water. Okay? But it took him days, right? So that's a big impediment if you just want to start playing. I'll show you how long it takes. So we need to do a few administrative commands, but these could all be in a README somewhere. They actually are. So this is an administrative command. I don't know why I called it OSH. This is another administrative command. Basically what we're doing is we're saying, hey, this account has administrative privileges. So let me see where I am. So I go to Oshinko REST tools. Okay, so this is also in GitHub. And what I'm going to do here is say make a template, which is a way inside of OpenShift to say make this thing that's very easy for people to just start with. They don't have to type in a whole bunch of commands. It's all of it put together, and they fill in some parameters. So that's done. Now, go into another Git repo. What is it in PySpark? Okay. So I'm just built this, and this only you have to do once, right? So the person doing this project would only do this once at the beginning of their project. Now, what I'm doing here is I'm building this final line that I'm doing here is what I'm actually doing is building the driver that can make a cluster. And so I'm giving it a bunch of parameters. What you're seeing is a bunch of parameters and a Spark image that we want to use. So a Spark container in particular that we want to use. Let's see if it works. There we go. Ugh. Yeah, it was the lines, right? Yeah, hold on. I think that's it. Let's see if that works now. Yeah. That's fine. The error message is ignore because some of the command worked before, so it's saying, hey, you already created these things. It's creating them again. Right? So now, if I go into my project that was empty before, there's 2 new things in there. And what those things are the drivers that can actually create a Spark cluster. So how long has that been? That's been about a minute, right? So far, maybe 2? Be generous, I'll say 3. Here, I'm going to make a Spark cluster. Ready? So this is the interface. I say I want to make a new cluster. I'm going to make this cluster be OF2. How many workers do you want? Don't say a lot, because I'm running all this out locally on my laptop. Okay, you get to pick how many I make because you were brave enough to answer before. How many do you, 2 workers? 3 workers? 3. Okay, so this will make a worker and a master and 3 workers. Okay, so if we go back here, there you go. The OF-2M is the master. This is actually creating the master Spark instance. And here comes 3 workers. We'll wait for the master to come up. So there, I now have a Spark cluster with 1 master and 3 workers. So how long did that take? 4 minutes? Not a day, not a couple days. So this is one of the benefits of this, and this is not necessarily particular to OpenShift and all that other stuff, although I kind of think it is. But what it really is showing is the power of having these kinds of frameworks, having containers, having an orchestrator and a scheduler which allows you, like Kubernetes, to specify in a file, here's all the things you actually need to do to spin this up in an effective way, and then a web interface where I can just click all this stuff. Right? And part of what makes this possible, the difference between containers and binaries. So when we usually install stuff, we install it and it just puts down the bits. What's the difference is with containers is it puts the bits and the configuration together. So it makes it much easier. I didn't have to install anything really on my laptop to start playing with Spark and to actually have to figure out how to wire this to that and do all that other stuff. It's just done by the value of the framework. Okay? So if we go back to this interface too, you can see that we've got now a Spark cluster called OF2, right? A master, 3 workers, they've all got their own IP addresses, and I have a URL to work with the master. Can you see that in the top? Shake your head, yes, I can actually see the top. If you, yes, okay, thank you. All right, so now we've got a Spark cluster. Let's do some fun stuff. So I'm actually going to spin up a web app now that does stuff on top of this. Well, the first thing I actually have to do is do another thing I have to do just once, which is put another template in that makes it easy to spin up this application. Right? So the nice people that I work with, have made this template, which will make it very easy for me in one command to spin up this whole application. Well, 2 commands, actually, but let me go back to this, and I need to go back up. Okay, so that's great. It's made the stuff I needed it to make. And now, I have to add a Mongo database, because we're going to store the results of our training into a Mongo database. Okay, so this is how hard it is to add Mongo to my project. I say add to project, I say Mongo. I'm going to use an ephemeral data store because I'm only doing this for this demo. Let's see, I've given this VM 14 gigs of RAM, so why don't I give this a gig of RAM? I can change how much, I can change how much memory I want to give it, leave it in the namespace, MongoDB. Because I care a lot about security, I'm going to make all the usernames and passwords admin, right? And if I go back to my project overview again, here comes Mongo. And now I have a MongoDB instance running. Right? And that's how hard it was to get Mongo running. So I've now built this whole infrastructure with Spark and Mongo, and it's time to actually add something else to the project, which was the whole application. This may take a while because the way it actually builds a Docker image in the middle, so I may actually, in the interest of time, switch over to the one I've already built. So here's Oshinko. Right? And I'm going to leave all of this alone. Where's the... Something went different here. Okay, I'm going to actually switch back to the other project, which I knew went right. Right? So, oh, that's why. It's not that something went wrong. My memory, the only thing that went wrong is my memory. It's not called Oshinko. That's not what I'm adding to the project. The name of the application is called Ophiclide. There it is. So that's what I want to add. So this application, and I'll explain it while it's spinning up. The only thing I need is this address of my Spark cluster. Right? Everything else I just leave the same. And I create it. And now this is going to go off and start doing it. It's going to do the build of a Docker image as well behind the scenes, which sometimes takes a while. I'm going to explain what the application does. Have any of you heard of word2vec, or turning words into state space vectors? Have you heard of that? The big data people in the room? Yeah? Is that a shaking of your head yes in the red sweater? It's hard because you're right in the way of the light. So for those who haven't, what it's basically going to do is take a corpus of text, like a big group of text, and what you do is you compute a base. I'm going to fudge it a little just to make it easier to explain. But what you do is you basically make a distance matrix between all the words in the text. You create similarity indexes between them. So based on computing these indices for every unique word found in the text, without stop words, so like no the, you can actually compute the difference between words. So you could put in a word like king, and it should then show you, well, words that are similar to this, that appear usually together or in the same contextual place in sentences, are words like ruler, monarch. It'll show, those should be the ones that show up related to that word. Does that make sense? Yeah? Kind of, you get the idea? What's also really interesting about this, and they've shown this in a paper, came out of the folks at Google, is you can actually do algebra with that. So you could do king minus man, and it'll give you the result of queen. No, king minus man, woman, queen, and it'll give you woman. Does that make sense? You can actually do algebra between the words. So what we're going to actually do, and I don't think this cluster is up yet. This one takes a while to come up. But that's the whole way to spin up the app. I actually have to start the builds. I forgot. I'll start that, and they'll probably be done by the... I'm going to build those in the background. So we're building the application. Ophicleide Web is a Node.js application. Ophicleide Training is a Python application. Right? So we're going to train on the data set, and then we're going to actually look at the results. So I'm going to come back to the exact same thing I built before. Here it is. Okay, and where's Ophicleide? So here's Ophicleide. Here's the front end of the application. So I already ran this with Napoleon. Right? So I went to Project Gutenberg. Project Gutenberg is taking old texts that are out of copyright and making them publicly available as EPUB, as .mobi, as PDF, and also as free text, just straight text. Right? So there's a whole bunch of books there. This is a collection of books, all in one file, that talk about the life of Napoleon. All right? And so I trained that model on all of this text, and I can go back here now, and I can query against it. Actually, before I do the query, let me start another model. Is that okay? Because I want to show you guys what we can do with this also. I'm going to do it against if we look back here, I can do the complete works of Jane Austen. Right? And I think that's this right here. Yes. So this is all the complete works of Jane Austen in one big 7 megabyte text file. And I'm going to actually train the model, and I'll show you doing it training behind the scenes. So let's add a model, and we'll call this model Jane. There's what it should download to work with, and it's training now. Right? So actually, the internet was kind of fast here. So if I open this up in Ophicleide, I can actually, there's Ophicleide Web, I can go into the containers that are running the train, and I'm going to look at training. Right? So we'll look at the logs for the training one. And if we go to the end, you can see it's starting to do Spark model. It's starting to, I'm going to say, it should keep following. Right? Go to end. Right? It's actually, you can see the Spark job running inside the container in the cluster. It's all being driven through the web interface. There's a Python application that goes, downloads the data, and starts to do the word-to-vector training. And so this is all happening behind the scenes. You can see it all doing all the work. Have any of you used Spark? I'm assuming at this conference, given that it was in the title, a couple of you have. And that looks like a normal Spark job, correct? It's not a trick question. You can say no. Okay, since silence means, of course, Steve, you are brilliant, and this is all perfect. So since nobody said anything, I am brilliant, and this is all perfect. Great. So that is the Spark job getting done, and now it's cleaning up. So the model should be done actually training pretty soon. It's training right now, but I'll show you now a query against off of Napoleon. So let's do a new word. What would be a good word to pick from Napoleon? Let's do Spain. And see how, Jorge and I were walking around last night. It looks like Napoleon tried to take Madrid at some point, but there was a plaza. What plaza was that? Where we saw the sign saying they stopped Napoleon? Which one? Porto Azor? Lezul? I'm saying it completely. Portal, Steve can't really speak Spanish very well. That's exactly right. So I'm going to do Spain. Oh, there is no Spain in its vocabulary. Really? Sorry? Say it louder. It was Czech Republic? Yeah, it was, or Waterloo, right? There we go. So there's Republic. I don't know, but see the part that maybe Spain never shows up. Because when I tested this, I did it against France, right? And so you find words that are really used in a similar context to France are England, Europe, Holland, war, Russia. When we do Republic, majority, partisans, monarchy, Cisalpine, does anybody know what that means? No? I don't either. And then embellishment. So that's done. But another one we can do, and I think this is kind of interesting, against Napoleon is let's do man. So man, the results of the text are man, woman, young, soldier, gentleman, and good. So these are all words that are very similar to the word man, appear in similar context to the word man, or are very close to it in relationships in Napoleon's work. I think at this point, hopefully, Jane Austen is done. So now let's look at Jane Austen's work. What's the closest things to man in Jane Austen's work? Woman. So that's very similar. But then we get girl, gentlemanlike, person, and respectable. So you can see that these authors use the word man in very different ways, except for man and girl seems to go together. Not man and woman, man and girl. Now let's do another fun one. Let's do girl in Jane. How does Jane Austen treat her girls? So words that are usually close to the word girl are sweet, charming, tempered, woman, and humored. So she actually has different characteristics for men and women. Let's try women, because that's actually the opposite of woman. What does she say about women? So she says charming, girl, pretty, simple, and child. She's not very kind to her female characters. Try Napoleon and see what he says about women. That was in Napoleon? Oh, I thought I changed it. Because I think she's actually even worse. I think she's worse to women. Or woman. I guess not. Man, girl, person, strain, and respectable. We can also look at characters. So in Jane, we can look at the word, does anybody know a famous Jane Austen character? I hate those novels. So did anybody read any, like Sense and Sensibility or any of those? Mr. Darcy. Let's look good. Nicely. I watched, I spelt it wrong. I watched Sense and Sensibility and Zombies on the plane. That was actually fun, because there was at least some good action in it. Now, that's not going to be in Napoleon. It's going to be in Jane. I'm not spelling it right. Does anybody know how to spell Darcy? Mr. Darcy? Let's put another name in. How about Jane? In Jane. No, that's not coming up. Emma. Isn't there an Emma? You guys. No. On Napoleon? So a D-A-R-C-E-Y? Just Y? Okay, here we go. I think something's gone wrong. Let's try, though. Yeah, it's saying it doesn't have Darcy in its vocabulary. Something's gone wrong there. I don't think it got all of the text. Any other words you want to try? Horse? Which word? In which one? Napoleon. I tried short, actually. When I was first playing with the data set, it doesn't come up. Apparently, no one's allowed to talk about it. So with that, we get neck, knee, excellency, sword, and mounted. Should we try it now in Jane? I'm really going to be sad if it says it about women. Favorite wife. Why was she so mean to her female characters? Wife, child, profession, and hat. I don't know where that last one's coming from. Okay, so that's all fun. I mean, I actually spent, after I started doing this stuff, I spent a good half hour just playing around with words. I'm actually a data nerd, and this stuff was fascinating to me. So the point of this all, though, was this is a Node.js application here. It's actually doing pretty cool stuff by showing those results in real time with these little cards and the top 5 results. So what you could be doing as a data scientist, or you as a data scientist could have built everything up until this web app. And then you could be giving to the people who want to be doing the analysis, you could say, just make your text available at a URL, and you can use this app to look at word associations. They don't actually have, you've already done all the hard work for them. You haven't had to install anything on their desktop, but you've actually now made a full, complete lifecycle app that allows people to do real data analysis. It's running in the same cluster. You didn't have to ask anybody for new machines, right? And actually, if we look at the metrics, you can watch the metrics happening. In OpenShift, you can watch the metrics happening. So you as the data scientist and the, let's see if we can get some metrics here. Let's go, what would be doing it? It would be here's the pods that do all the work. These are the workers. I think metrics is turned on. Right? So there's all the metrics. Here you can see the training. That's probably the training happening right there. Right? So you could actually have metrics into seeing how people were using your app, how much resources you were using, but it's all in one cluster. It's not this, okay, I'm going to go do this off in one land and do this all on these other machines, and then I'm going to somehow migrate all that data and all that stuff to another machine and figure out how to put it together. You can keep iterating web apps very quickly against those data sets because you've converged both your application and your big data infrastructure. This can actually handle auto-scaling. So if everybody started hitting it, you could actually set things so that the metrics, the Spark drivers, the workers, you could actually scale up more in real time. And the platform would handle it without you having to do anything at all. Okay? So that's the end of the demo. Actually, I need to go back to my slides. And we'll wrap it up. So wrap up. We can still do analysis on our desktop if we want. I assume most of the people who are here were big data people, right? Not necessarily web apps people. You may have written some. But you can still do analysis on your desktop. That hasn't stopped. But now we can easily integrate data or APIs. I was pulling off a website that could have easily been an API call to the Twitter stream, right? You could have done this exact same textual analysis. How many of you were here for the Twitter talk right before this? A few of you, right? And so you remember how he was saying you could segment out all this stuff? You, as the data scientist, could build this web app allowing people to put in different filters for the training set, right? So you could say, I want, you work for Nike, or actually I'm in Europe, so you work for Adidas, or Puma, right? So, or Fila, which is better here in Spain? Adidas? Okay. So you work for Adidas, and you want to watch stuff that's happening in Twitter around Adidas to see if you can catch a trend. Well, in that web app, it could have been just as easy to say, I'm going to do a query to the Twitter Stream API. And what you could allow the users to say is, how do you actually want to segment that Stream API? I want people between the ages of 18 to 24, living in Spain, and you could put all that in, have them hit submit, it would pull it from the Twitter stream, train the model, and they could start playing with the model right away. Right? No need for you to sit there and make something on their desktop or make something custom. You build this once and they're good to go. You could also put in a whole bunch of other statistics and machine learning stuff inside of there. I just use Word2Vec. It's pretty similar. It's pretty simple. Relatively, if you look at the code, it's relatively easy to implement. But you could have put a whole bunch of other models in that same place, giving them a suite of things that they could be hitting against from a web interface. And you could build much more interactive web applications, right? You could do things with graphs and trends over time and all that other stuff because the web now allows that. To do this on your own, the slides will be up later, so I show you how to bring up OpenShift if you want. There's two different ways. To get Oshinko, which is the thing that makes the Spark cluster inside of OpenShift, there's the links for it. There's the two pieces that you do. And for the word analysis, that's Ophiclide. I complain to the people who made this app all the time, why did you name it that? That is the worst name ever. But they somehow think they're witty. So it's called Ophiclide, which I think is an instrument. And that's where that all is. And they love pull requests. This is all open sourced, including OpenShift and everything else in it. Okay? So, does anybody else want a picture of that slide? I'll share the slides, but yeah, okay, there's a flash, another flash. No more flashes. We're all set. So, Fiend. Thank you.